हेलो एवरीवन, आज हम बात करेंगे लेक्चर नंबर 4 में regarding the electric field of the dipole at the axial point and the equatorial point, and many other topics are also there. So let me start with in the continuation of the last topic. As we discussed, I'm just giving a small recap that what we did in the last lecture. We did the electric dipole, what actually the electric dipole is, and how to calculate the dipole moment of the net system. You know that the electric field and electric dipole are the vector quantities, so you must have the knowledge of vector algebra to calculate the net resultant of any system, because you will be having different vectors at different angles and you have to calculate the resultant vector of these vectors. Okay, so in this case the electric field intensity we are calculating at the axial point and the equatorial point. We know that I discussed in the last lecture that electric field at the axial point, that means on the line of the electric dipole, and one is at the perpendicular line from the dipole. Fine. You also calculate electric field with potential. Okay, so electric potential is also calculated. We will be discussing in the further chapters. Okay, so let me start with the electric field intensity at axial and the equatorial point. Now I have taken the dipole, a small dipole here. मैंने बताया था आपको, मैं हर चैप्टर में आगे अपने डाइपोल को पी वेक्टर से दिखाऊंगा, मुझे माइनस क्यू प्लस क्यू में बार बार नहीं दिखाऊंगा, ठीक है, दैट इज अंडरस्टूड, एंड दैट इज पी वेक्टर वी आर टेकिंग. दिस पी वेक्टर इज हैविंग ए पोजिशन दैट इज ऑन द एक्सियल एंड वन इज एट द इक्वेटर. सो दिस ए पॉइंट इज एट द एक्सियल पॉइंट, एट द एक्सियल पोजिशन, दैट इज एक्सियल पॉइंट, एंड दिस बी इज एट द एक्सियल पोजिशन ऑल्सो, and this C is at equatorial. Okay, so now when you do this you come to know that EA is 2 kp by r cube. मैंने बताया आपको, ये मैं डेरिवेशन पार्ट नहीं ले रहा हूँ, आपको मैं एक ब्रीफ, एक क्रैश कोर्स दे रहा हूँ जिसके अंदर मैं 20 मिनट में जो आपको पूरा रिवाइज करवा दूँ. ठीक है, ऐसा नहीं है कि हम ये नहीं करवाएंगे, हम बोर्ड के जो वीडियोस हम डालेंगे उसमें हम डेरिवेशन पार्ट भी डालेंगे, तो आप वहां से कवर कर सकते हैं, बट टिल देन यू प्लीज कंटिन्यू विद योर बुक्स. ओके, सो दैट इज 2 kp by r cube, and where this p is the dipole moment, that is q into the separation between the charges, and k you know that from the very first lecture that k is 1 by 4 pi epsilon naught, and that is having the value 9 into 10 raised to power 9. Okay, so this is 2 kp by r cube. And when you find the electric field, you know that electric field is a vector quantity. Definitely your question will be arising in your mind that what is the direction of it. So that is I cap. So in the x direction, similarly the electric field will be from negative to positive also in the direction of the the p vector. आप देखिए, यहाँ पे देखिए, ये जो E है इसके फॉर्मूले में P आ रहा है, आप कह रहे हैं इलेक्ट्रिक फील्ड वेक्टर है, तो इसके फॉर्मूले में भी एक वेक्टर आ रहा है, तो जो डायरेक्शन डाइपोल मोमेंट की होगी यहाँ पे वही डायरेक्शन आपकी इसकी जो इलेक्ट्रिक फील्ड है ऑन द एक्सियल लाइन वही होगी. लेकिन जब आप इक्वेटोरियल पॉइंट पे निकालेंगे आप देखेंगे दो कंपोनेंट टूटते हैं, राइट, इन दिस डायरेक्शन, इन दिस डायरेक्शन. सो इन दिस डायरेक्शन ये दोनों जो हैं कैंसिल हो जाते हैं वर्टिकल लाइन में, और जो नेट रिजल्टेंट बचता है वो सिर्फ माइनस x डायरेक्शन में बचता है. और मैं माइनस एक्स ना बोल के इन जनरल ये बोलता हूं कि जो माइनस और प्लस अपोजिट टू द डाइपोल. ओके, सो नाउ दिस इज लेट मी टेक द पॉइंट अगेन, दैट इज p vector, and at the equatorial position the electric field will be coming out from positive to negative. This is the point to remember here. Okay, so in the derivation part you know that electric field will be coming out in the opposite direction from positive to negative, and at the axial it is in the same direction which is of the p vector, and the p vector is negative to positive, that is plus x. So plus x is represented by I cap. Okay, and similarly if the point is here, please don't get confused with this. This will be having the direction is I cap, the same. Okay, and what is r here? This r is the distance. Please let me write this. This r is distance of the test point from center of the dipole, for example, like suppose you are taking minus q and plus q here, and this is the center of this. You will be calculating, suppose this is a point and this is the test point here. Okay, so this test point, this will be the distance r. Clear? And you know that we have taken this distance as a, and in the derivation part you very well know that how to proceed this. So let me come to the topic again. So I discussed about the axial point and the equatorial point, that is 2 kp by r cube, and what is at the equatorial point, this is kp by r cube, यानी कि आधा है उससे. तो आप इक्वेटोरियल की एक्सियल की और इक्वेटोरियल की अगर रेशो निकालेंगे, दैट विल बी कमिंग आउट एज 2:1. सो दैट मीन्स यू कैन राइट इट एज E axial by E equatorial will be coming out 2/1. So ratio is 2:1. Fine. Now, and please do remember the direction of that. One is in opposite direction, one is in the same direction. So at the equatorial position, the direction will be in the positive to negative, and at the axial it will be from negative to positive. Now you are very familiar with this diagram where you are taking the general point here. I am discussing now general point. This is not the equatorial point, this is not the general point, but from this general expression you can find out the result from the for the axial point and the equatorial point. So now I am taking a vector p vector here, but the point is here. So this point will be having distance r again from the center of this, but you know that this theta inclination will result in resolution of the p vector in p sin theta and p cos theta. Now आप अब इसको ये क्या आपने जो p cos थीटा है और जो p sin थीटा, आपने इन दोनों को अलग अलग डाइपोल मान लिया. अब देखिए, अगर मैं इस पॉइंट की बात करूं तो इस डाइपोल के लिए क्या ये इक्वेटोरियल पॉइंट हुआ? लेट मी टेक द पॉइंटर हियर. सो दिस डाइपोल, for this dipole, this A point, which is the test point, is acting like a equatorial point. So we will apply the formula for the equatorial, and for this vector it is on the same line. Okay, if it is on the axial line, its electric field will be in the same direction, that is E1. और आपने कहा कि इलेक्ट्रिक फील्ड अगर मुझे इसकी निकालनी है जिसके लिए ये जो पॉइंट है ये इक्वेटोरियल का काम कर रहा है, तो उसकी डायरेक्शन इससे अपोजिट आएगी, तो मतलब इससे अपोजिट आएगी. अभी मैंने बात की. ओके, तो आपने क्या देखा कि ये जो E1 E2 है ये इस तरीके से इंक्लाइंड है 90 डिग्री पे, तो जो इनका नेट आएगा वही आपका आंसर आने वाला है. लेकिन यहाँ पे हमने डिफाइन किया कि जो हमारा नेट रिजल्टेंट आ रहा है वो इस E1 के साथ अल्फा एंगल बना रहा है, मतलब हमारे जो रिजल्टेंट वेक्टर है उसकी डायरेक्शन आ रही है. Okay, we will be calculating it in the term of tangent. So what is the significance of this alpha? This alpha is giving you the direction of the net resultant, net electric field with respect to the E1. Okay, but can you please shift this p vector here? You know the vector algebra, parallel shifting of the vector से कोई फर्क नहीं पड़ता है. तो ये p vector मैंने इधर बनाया, this theta is also theta, this angle is also theta. So now the resultant vector is E. Okay, please mark it is E. So E में और P में जो एंगल है, एंगल बिटवीन E and P is थीटा प्लस अल्फा. तो थीटा तो हमें दिया होगा, ओके, लेकिन अल्फा हमें निकालना होगा. वो कैसे निकालेंगे? सबसे पहले तो हम E1 और E2 निकालेंगे जिसका हमें रिजल्टेंट निकालना है. अब मुझे बताइए जो E1 है ये किसके लिए है? इस वाले वेक्टर के लिए, इस वाले डाइपोल के लिए. जो P cos थीटा आया है इसको मैंने P1 मान लिया, मतलब मैं इसको अलग से एक डाइपोल मान रहा हूं और मैं कह रहा हूं कि जो टेस्ट पॉइंट है वो इस वाले डाइपोल के लिए एक्सियल पॉइंट है और जो दूसरा डाइपोल है उसके लिए हमारा A पॉइंट इक्वेटोरियल पॉइंट है. तो हमने रिजल्ट निकाले 2kp बाय r क्यूब. मैंने यहाँ P1 लिया 2kp 1 by r क्यूब, बट P1 वैल्यू इज P cos थीटा. ऐसे ही मैंने E2 लिया, लेट मी करेक्ट इट, दिस इज K. Okay, because this is equatorial point, so this is kp2 by r cube. You will calculate it as kp. you will put the value P2 as P sin theta by R cube. Okay, so now E net is E1 square plus E2 square Kp by R cube 3 cos square theta plus 1. When you represent this as a resultant E1 square plus E2 square, this sin theta and cos theta will become sin square theta plus cos square theta. You will come to know that one expression will come out in the derivation part, that is 4 cos square theta plus 1, and 4 cos square theta plus sin square theta. Out of that 4 cos square theta, 3 cos square theta will be taken out, and you will be left with sin square theta plus cos square theta, that will become 1. So you will be living with 3 cos square theta plus 1. Okay, so Kp by R cube 3 cos square theta plus 1, this is the net resultant. Now the question is, what is the angle? What is alpha here? So I have drawn the diagram in a I have oriented the diagram. The P vector was like this, okay, so, and E vector was like this, and E2 was like this. So I have just rotated this angle just to let you understand. Okay, suppose now that was E1 was at the angle this, and and this my hand is P vector. Okay, so P vector, if I orient it like this, so this will become 90 degree. सिर्फ आपको समझाने के लिए, ताकि आप अच्छे से जो ज्योमेट्रिकल जो फॉर्मूले आप लगाते हैं आप लगा पाएं. सो दिस इज E1 and now this is E2. So E2 and E1 are 90 degree, are at 90 degree, पहले भी थे अभी भी हैं. तो आप देखो इस ट्राइंगल के अंदर इस E2 को मैं यहाँ शिफ्ट कर सकता हूँ. तो टेंजेंट अल्फा आप निकालेंगे, दैट इज E2 by E1, and you know that E2 is you calculate Kp by R cube sin theta, Kp sin theta by R cube, and one is 2 Kp cos theta by R cube. When you put the value, you will be having value tangent theta by 2. So alpha is coming out. Alpha is tangent inverse tangent theta by 2. For the medical students, for the NEET exam or the NEET students who have not studied regarding the mathematics about the inverse trigonometry, this is alpha equals to tangent inverse tangent theta by 2. क्या फर्क होता है ट्रिग्नोमेट्री में और इनवर्स ट्रिग्नोमेट्री में? ट्रिग्नोमेट्री में क्या करते हैं आप, वैल्यू पुट करते हैं, एंगल पुट करते हैं, वैल्यू आती है, और इनवर्स ट्रिग्नोमेट्री में आप वैल्यू पुट करते हैं, आपको एंगल मिलता है. सो दिस विल बी द अल्फा एंगल मिल रहा है, टेंजेंट इनवर्स, दिस इज इनवर्स ट्रिग्नोमेट्री. And I told you that what is the angle between P vector and E vector? This P vector and E vector is theta plus alpha. Theta will be given to you, and alpha you are calculating, that is tangent inverse tangent theta by 2. Okay, if you know the theta, alpha can be calculated by tangent theta by 2. Okay, so in this way the general point is taken. So please have a look on that. That is E net resultant in the general point. At the general point, it is coming out as Kp by R cube 3 cos square theta plus 1. If you are taking the axial point, what is the angle? If you are taking the, please see, this one is, if theta is 0, that means you are on the axial line, and if theta is 90 degree, it means you are at the equatorial point. Let me put this formula, or put the values of these angles. Theta equals to 0, that does mean axial line. Theta equals to 90 degree, that does mean the equatorial point. So let me put this here. You will have the same formula which we have written here. Okay, so that is 2 Kp by R cube and Kp by R cube. So that was a general expression for that. Then after, this is a question given to you. Okay, and in this question it says that this is P vector. Okay, this is P vector, and one point is here, this A point is here, and one B point is here. Okay, तो पूछ रहा है कि यहाँ और यहाँ, अगर मान लीजिए ये इससे x की दूरी है, इससे y की दूरी है, यानी कि जो हम जो फॉर्मूले लिखते हैं 2 Kp by R cube, that R is given as x and y. Okay, so if it says x equals to y, what will be the value of EA and EB, and what will be the ratio? So let me write it. That will be simply it at this point, this will be EA is 2 Kp by x cube, and this is EB is Kp by R cube. You please see how simple it is. So Kp by R cube, but this R is y cube. Now it says when x equals to y, as x equals to y does mean that x equals to y, they are having the value EA is 2 kp by x cube, and if I divide it with EB, okay, so it will become kp by y cube. So you will cancel out this kp in kp, y cube and x cube, so left with 2:1. So this is your answer. Okay, and when it says that EA equals to EB, what is ratio of x equals to y? How can you calculate that? You put the formula. Let me erase it. Please let me write it again. So EA is equal to EB. This is given to you now in the second part, and when EA equals to EB, you know the formula 2 kp by x cube equal to, that is kp by y cube. Okay, so 2 kp by x cube, kp by y cube. Now you are asked for the ratio of x ratio y. Okay, so x cube or y cube, then definitely it will be x cube by y cube. So x cube by y cube is 2. Okay, so x by y will be 2 raised to power 1 by 3. So this is your answer. I think I'm clear to all of you. So please understand the topic of the electric dipole. This is the second lecture regarding the electric dipole. In the first lecture I discussed the basic concept, in which we did 2 or 3 numericals, and in the same way we have discussed now the electric field for the dipole at different points, and these points are classified as axial point, equatorial point and at any general point, and from that general expression you can extract out the formula for the axial point and the equatorial point. So this is simple, and you can calculate 2 kp by r cube and kp by r cube. I have also written in this formula as potential. In the potential part I will be discussing, but please do remember, when you calculate it at the equatorial point, the potential is 0. Okay, आपने पढ़ा तो हुआ ही है, मैं आपको अभी बता दे रहा हूँ कि पोटेंशियल इक्वेटोरियल पॉइंट पे 0 आती है, और जो एक्सियल पॉइंट है वहाँ kp बाय आर स्क्वायर आती है. दैट डज मीन यहाँ आर क्यूब था इलेक्ट्रिक फील्ड में, और इधर आर स्क्वायर है. ठीक है, सो kp by r square, one is kp by r cube, but at the equatorial point the potential is 0. Okay, and this is kp by r square, and potential is a scalar quantity. And when you find out the general expression for this, you will be discussing in the next video, that is kp cos theta by r square. Let me see, have I written here or not? Okay, so this was a numerical here. Now yes, I have written here the concept of potential for the dipole. If this is P1 and this is P2, and suppose this is a point A where you are calculating the potential, you see that this P2, for the P2 the A is equatorial point, and for the P1 it is a axial point. Axial point पर potential होती है, equatorial पर नहीं होती है. Axial point पर kp by r square होती है, equatorial पर 0 होती है. तो आप V1 plus V2, because it is a scalar quantity, you can add them directly. So kp1 by r square plus 0 and kp1 by r square is your V net. In this case, you can say this is a small example or small numerical for the potential. But in the general case, I am giving you the whole idea. The same diagram will be there as we discussed in the case of electric field for the general point in the case of dipole. Okay, so voltage at any point, like that kp by r cube was √3 cos square theta plus 1. Here this is kp cos theta by r square. So when cos theta is 0, that does mean you are talking about the axial point. So theta will be 0. Theta will be 0 means 1. So kp by r square is left. Okay, but please see the general expression how I have written here. This is kp cos theta. Can I write it as p vector dot r cap, because r cap is a unit vector which is having the magnitude 1. But when you open this dot product, you will be having p dot r cap जिसका magnitude 1 है. Okay, this is cos theta. So p cos theta can be written like p vector dot r cap. you know that r cap is a unit vector which is represented as vector divided by its own magnitude. That means r vector divided by own magnitude, that is r. Okay, so r square was there in the denominator, and when r is additional now, so that becomes r cube, and you left with the formula in the vector form kp vector dot r vector by r cube. And if you verify the formula, that potential is a scalar quantity, and on the right hand side you are getting p vector dot r vector, which is a dot product and dot product, and that is, you know, gives us the scalar quantity. So that's why the potential is a scalar quantity. I'm touching all the angle, okay, all the angles here. So let me put the full stop here for this lecture, and in the further lectures in the following classes we'll be discussing. So meet you in the following classes. Till then, thank you, goodbye.